Hi, we're here today at Roy Blankenship's Amp Repair Shop. How you doing, Roy?
I'm good.
I understand you're out in North Hollywood here. You do a lot of work for the local stores and a lot of the rock groups.
Yes.
So what's this amp you're working on today?
Okay, today we have a black-faced Fender Deluxe Reverb, which is a super popular amplifier. In fact, I'm currently getting requests to build clones of these because the collectible value has gone so high that it's almost more worth it if you want to have this particular sound to clone it, to start with a completely new build. So I've been building some of these. This particular amp just came in for service, and so first thing I wanted to do was zip it apart, take a look at it, physical look at it, and also put it through my test gear to see what's actually going on.
So you're taking apart this Fender to see what the problems with it are?
Well, the first thing I'm going to do is check the fuse, which looks good. I'm going to plug it into this device on my bench, which is called a variac. This allows me to vary the AC going into the device. If there's a problem with the device, when I first turn the device on and turn the variac up, there's a meter, another second meter on here for amperes that will give me an idea if there's an internal problem. If there's an internal short in the amplifier, the ampere meter will jump drastically, and that way I'll know there's already a problem and I don't need to go any further. This saves fuses.
Ah. So you start at a very basic level. Where is the voltage? Where are the amps? What's happening inside the box?
Right. So I've cranked it up to 120, which it seems to be happy so far. This could be a noise-related issue. This is an older amp. A lot of old amplifiers have dirt, corrosion, and component deterioration issues.
And it's just from traveling on the road and being in the weather and natural living like an animal, so to speak.
Yes.
Gotcha. And now you've plugged it into the oscilloscope, is that correct?
Yes. And I have, these devices are called dummy loads. These simulate the speaker. A tube amplifier wants to see a speaker load at all times when it's on. So the whole idea is to, like, this is for 8 ohms, this is for 16 ohms, and this giant one here is for 4 ohms. So that it replicates it's as if the amplifier is looking at a speaker. Then I plug into the oscilloscope, and this is called a sine wave generator. Generates a sine wave that goes into the amplifier, and then what we look at on the oscilloscope is the reproduction of the sine wave, which is looking pretty good on here so far.
So this is almost as if you'd plugged it in with a guitar and it was playing.
Yes, I'm kind of replicating that whole...
Kind of replicating that internal
that whole thing.
Electronic.
And so far this is looking good, and it's putting out 14 volts, which now to determine the output power of the amplifier, we take the output voltage, which is 14 volts squared, divided by the impedance, which is 8.
Uh-huh.
So,
and to backtrack just for 1 second, what was the complaint or the description of the symptoms of how this amp was malfunctioning?
so far, I haven't contacted the people to know that yet.
Okay.
So I'm just assessing it on my own.
I gotcha.
Because after you've worked on 10,000 amplifiers in your life, you can just look at them and go, aha! I know what's wrong with this one.
Gotcha.
So now we're going to turn the amp off and turn the variac off so there's no AC voltage going into the amplifier. That doesn't mean it's necessarily safe to work on, because there are places in the amplifier that will retain the voltage, and once you get the amplifier apart, you have to make sure that those voltages are drained out. Now, Deluxe reverbs in the Fender line, Deluxe reverbs and Vibrolux reverbs do not have what are called drain resistors, whereas some of the other ones like Super Reverbs, Pro Reverbs, Twin Reverbs have what are called drain resistors, so that they're not as volatile or dangerous.
Gotcha. So there's this residual current left in the system.
The residual voltage.
Yeah, through the voltage. Gotcha.
So okay, this amp has had some service on it. I'm sure this looks just like a bed of snakes to everybody. You can see that the power transformer has been replaced. The choke and the output transformer are original, and on a Fender amp, you can find out what year it is by looking at the transformers if they're original. Like on this one, there's a part number, and then there's a numerical code. 606 is Schumacher transformer in Chicago. That's their EIA code, and then the next digit is the year, and the next digit is the week. So this says 602. So this transformer was made second week of 1966. So these two transformers are in fact original. This one was made 14th week of 1966. This, however, is a replacement transformer, which that happens, and it's a Mercury, which is a very good brand.
And now, will you pull out or test these components separately?
No.
No.
Generally speaking, there are a lot of visible cues. So one of the first things I want to verify is that there are numerous types of components here. Underneath this little doghouse, underneath the amplifier, these are called electrolytic capacitors. And in this unit, they've been replaced, and rightfully so. The original components were designed to work for 10 or 15 years, and by now they're 50 years old, and so they definitely need replaced. There's a whole trend in our industry about people who want an amp that's original, which I'm not quite sure what purpose that serves. If you actually want to play the amplifier, you need to replace components. Just like if you had an old car, you wouldn't want to run an old car on 50-year-old tires. This is kind of the same thing. But for some, originality means value, which is a kind of a bizarre, warped, distorted thing that happens in our society.
Yeah.
These have been replaced, and they also replaced these. These are resistors here. Those have also been replaced with a heavier duty called a metal oxide resistor for reliability.
So some new components are better because old components were designed to have a certain lifetime.
Yes, old components deteriorate, and I'm sure all the tweakers are having a fit right now if they're watching this, because they think that when they find some old, what in the car business we call it a barn find, they find some old amplifier in a closet, and they're so happy that they've found this device that has all original capacitors, and it still works. And it will work for a while, but pretty soon you're going to be endangering your longevity of the amplifier by operating it with old crappy components that are out of spec.
So now we're looking at the main circuit board, or what are we looking at inside there?
Yes, this is the main circuit board. Now this is people. Some people call these tag boards. Some people call them circuit boards. These are made of phenolic, and they have a tendency to absorb moisture. And they warp, and I don't know if you can be able to see it on camera or not, but this has actually warped upward here. There are small humps in the board, and the consequence of that is only in this one part right here, where there's this one resistor that runs parallel to the front panel. As these boards would warp, they would cause this resistor to fracture. So a lot of Fender amps will be intermittent. They'll say, well, it'll be fine, and I'll bang it on the top, and then it'll start, it'll cut in and out. Well, that's because that one resistor has fractured and needs to be resoldered.
And phenolic was just what they used as a substrate for circuit boards back then.
Yes.
Gotcha.
Yes, and in fact, they still do today. And later on in Fender's life, they actually dipped these in wax in an attempt to stop the moisture absorption. I've seen, not in California, but in Florida, where it's very humid, I had an amplifier come in that had absorbed so much moisture that I could put my meter on volts and put one of my probes here and measure 6 volts right on the board. Not on a component, but right on the board. I was measuring 6 volts because it was so conductive, which the consequence was
voltage leakage, in other words, out of the components. Gotcha.
Yes. So this amp's looking pretty good. I'm betting there must be some sort of noise problem.
Now I see there's covered, what look to be covered tubes and uncovered tubes.
Yeah, these are called the preamp tubes. These the small ones. There are so many different brands, and there will actually be brands labeled one thing that were actually manufactured by somebody else. It's a very incestuous business. And like as I look at these, some of these are actually labeled what they really are, which is amazing.
Would those be American tubes or Taiwanese tubes
Well,
or German?
Well, okay, now this is a German tube. This is a company called RFT that makes a really good 12A T7. They're very rugged. This tube is labeled Philips, but is in fact made by EI in Yugoslavia.
Philips subcontracted to EI. Huh?
It just seems like some companies will buy mass quantities of tubes and then put
Gotcha.
their own private label them.
Gotcha.
This is a Chinese 12AX7, which these are great. There's a whole thing in the industry where people will be disrespectful of certain manufacturers or certain companies or certain countries who are making product. The reality is there's good stuff from everybody and there's crap from everybody. So
Yeah.
now here's the tube labeled RCA, and it is in fact an RCA. You can tell an RCA tube by virtue of the fact that it has an octagon around the frosted on label on the tube. This one says 12X7A, and there's the octagon around it, which means it truly is an RCA tube.
Now, is it a vintage RCA or recent
Yes,
RCA?
it is. No,
Wow.
there have been these tubes haven't been made in this country for years. If this said 12X7A and had little frosted dots running down, that would make it a GE.
I see, but this one is for sure an RCA.
That's for sure an RCA. And then this tube is made by JJ, which is in Slovakia, and these are a very good tube. They're a very neutral tube. And
Now, will you test these in series or separately or do both? How do you?
well, since we're not having any severe malfunctions, I probably won't really be testing them at all.
Gotcha.
At this point, I'm going to let's go on to a different device that has more obvious problems.
Okay. So, Roy, I see you have another beautiful amp here. What is this amp?
Okay, this one is a silver face Fender Vibrochamp. This is from the 70s, and the customer complaint was that he feels like it's sounding weak and he just wants me to go through it and do my thing. Now he's already replaced the speaker with an aftermarket speaker. The speakers on these things were a little wimpy from the factory, so this is sometimes a good thing.
Out of curiosity, would that be an American speaker, a German, a Japanese, Chinese?
Well,
the original.
The original speaker was probably American.
So, in your opinion, do you think there might be a problem with the replacement speaker, or is it? You don't know yet. You have to do a little more.
Right. Yeah. As soon as I whip it open, we'll be able to tell more about it. Now, one of the things that happens on the 70s era Fenders is they had these power cords. It's a grounded power cord, and it has a vinyl jacket on it. Usually these pull away and expose the conductors. That doesn't mean the cord's bad, and it's interesting that I see a lot of these cut off and they put a replacement on there. This cord isn't shorted just because this jacket has come back. But on the subject of replacement plugs, a lot of guys go to Home Depot and buy these things that have screws sticking out of them that are really hazardous, and they end up scratching you and being really harmful. It's not that much harder to pick up. This is a Leviton brand plug, and you can see how it's safe. There's no, it completely encases all the electrical components, and it also does not have screws that are going to come out and jab you like some of the cheap ones from Home Depot. So this is a worthwhile investment when you have to have a replacement plug. Because anytime this grounding lug gets broken off, you're opening yourself up to a shock hazard. Sometimes people break these off on purpose. If they live in an older house and they don't bother to buy the adapter, they just break this off and then go for it. And then meanwhile, when they step on stage and plug their amp in and put their lips to the microphone, blue sparks fly, and they wonder why. That's why.
Amazing.
You're not grounded. You need to be properly grounded.
Yep.
It's totally worthwhile to have a good drill. When I first started doing this in 1991, I bought a Makita that I still have, and it's never given me a single problem, but I can hear that the motor bearings are getting worn. And I just happened to find this one at a tool shop, so I was able to get, because I already had the correct battery and charger. That's something totally worthwhile. The other good thing to have is one that has a clutch, so that you don't round out your screws. You know, when you get up a certain amount of tension, the clutch out. That's very valuable, and I've learned that the hard way from back in the 70s when we just used a drill with a screwdriver bit. And we'd round out screws, or we'd end up going through the cone of a speaker or some other. Okay, now this is what I call an abortion. The original multiple capacitor in this amplifier, which is this aluminum, it looks like a tube, but this is the original capacitor in here. And in fact, here's the date code on it, 235, Mallory's EIA code, and then 78, 39, 39th week of 1978. So that would tell me that this is a 78 or 79 amplifier, which is verified by the date code on the transformer, 606 Schumacher, like we saw before, 78, 38th week on that one.
So a lot of this is still original.
Yes, a lot is still original. But this is what happened to this one that is a travesty. This one has all replacement tubes in it, which is not a horrible thing. But when the original capacitor went out, they decided to try and substitute modern electrolytics that are not the correct format in here. And you can see what's happening here. This is flapping around in the breeze. This is really wrong. This is not good. So my method of fixing this is I'm going to tear all this out and replace this original capacitor in here with the correct thing, and put this amp back to normal, and then it'll function properly. This is, to me, this kind of work is personal pride, and when I see work like this, it makes me wonder what the person was thinking. If it was the hobbyist that did it, if this was a real repair guy that did it, he needs to be found and castrated. That's just, there's no excuse for that.
In other words, they took the cheap way around.
They took the cheap way around. These parts are generally available. They're not super expensive, and this is very disappointing to see something like this happen. So for the safety of the tubes, remove the tubes. I have a whole bunch of little cat food cans and tuna cans that I keep hardware in. That way you can keep track of things. If you take an amp apart and you just spread things on the bench, first thing you know, you're knocking something on the floor. So keeping everything in one area is totally worthwhile.
Makes good sense.
So one of the other necessary tools for this kind of operation is a good soldering iron. It's amazing to me the people that try and do their own little hobbyist repairs, and they have some little
$7
yes
Junko thing.
Yes, that doesn't create enough heat, because that to me is the main problem. Weller and Heiko are the two main brands of soldering iron that people seem to use, and the Heikos to me just don't have quite enough oomph. So I've always stayed with the Wellers, in spite of the fact that sometimes they're problematic.
Weller's been around forever, right?
It's,
I had one as a kid.
yeah, and now they've been bought by another conglomerate,
Oh.
which isn't that consequential. So the other thing that's important to have is, and you can hand it to me right there, that black gun behind you. Keep going down. There you go. Nope, next. This is a real solder gun. You can't use this on a circuit board because it'll burn the trace right off. But you need to, this is 200 and 300 watts, and this is what you need to have to remove this kind of device, this one of these old capacitors. So I'm gonna get it warmed up a little bit. We're gonna take the solder.
And from what I know, the basis of a really good solder is to warm up both ends.
Yes.
And then warm up the middle.
Yes.
But right now you're doing removal, correct?
Yes, and you see how that came right off.
Yep, pathetic. Well, good in a way, because you're trying to get them out.
Well, I have adequate amount of heat, so I don't have to sit on the solder joint for any period of time to make that
Gotcha.
happen. So we're going to be rid of these things pretty shortly here. Okay, and then always remember to put that in a safe place, as my Makita will tell you.
So you've extracted the dead modern components.
Yes, and actually they left the long leads on them, and these could essentially be used in, because they have a fairly modern date code on them, they're not very old. This is something I would recycle into like a dealer repair.
Gotcha.
Because I hate wasting components if they're good. If they sound bad, then they deserve to be wasted, but in this case, I would be interested in recycling those back into the mix. Now, capacitor into the chassis by a massive amount of pooled solder. Trying to make it look as pretty as I can. So when people look in, they'll go, aha, that guy had some pride in his work. Rather than the reaction that I had when I opened this up. I'm like, oh, great. Okay. Now we'll let that cool for a minute. And then what I want to do is I generally I have a couple little probes here that I use. There's debris from the flux that has accumulated on the chassis, and so I kind of want to get that off. Not for any other reason than to me it looks aesthetically better than to have some huge buildup of crap around your solder joints. Then I save my old toothbrushes and take my flux remover. This is some dangerous volatile stuff. It will eat anything plastic, so you have to be careful about the application of it. But then you go like this and like this. And it looks like new, because it is. So in essence, that's our repair. Now the next thing I have to do is essentially reconnect these wires where they actually belong.
And then, of course, you will test this on the oscilloscope before you completely reassemble, or how will you test your repair before you close the...
Yes. You always put it on the oscilloscope with the correct load. I'll re-rob this wire from this is one of the original pieces of wire, but now correct solder technique actually is that when you put your soldering iron back into the holder, there's some tin on it. That keeps it from corroding. I learned backward, and I've never really been able to go back the other way. But essentially, this is how you should return your iron. But I got into the habit of doing it the opposite way, where I clean it before I stick it back in the holder. So it just means that I go through more solder tips. It's the only consequence of that.
But you get a better working solder inside the unit.
Well, I don't know. That's debatable. So, you tin your wires first. I use an 800 degree tip, which is excessive. If I left this on a circuit board too long, it would pull the traces off. The more popular temperature is about 700. But it's not just the temperature. There's a certain current. There's amperage that is involved too, because I've seen a lot of guys who have the Heiko irons, and they'll have them up to 900 degrees, and they still can't really get things to happen. Whereas with the Weller, even with the 800 degree tip, it's like it's got a lot of horsepower. It's gonna melt your solder joint like instantaneously. Okay, now we're gonna reinsert this one into the middle.
And now we're making the actual connections to the circuit board. I mean, to the circuits.
Yes.
To the rest of, yes.
Yeah, this is. In fact, this wire seems like it's been flexed a little bit too much, so I'm going to desolder it and create a new connection.
So there might be an internal break to that wire?
Yeah, right down here toward the end.
Yes.
It looks like it's, so snipping it and resoldering it gives you a complete new surface to deal with. Which to me looks neater anyway, because a lot of times what people will do during assembly is if there's too much heat on this older poly covered wire, there'll be a melt mark and it looks sloppy. So I like a fresh, clean edge.
But now that reused wire is not too short?
That's what we'll find out here in a second. I have literally miles of wire in this shop, so
Yeah.
if it is, it's
Yeah.
not a problem to get another piece. Okay, so now, this is an interesting scenario that we should talk about. This is a huge hole that I'm trying to fill up with solder. So there's a huge blob of solder on the downside of this. So rather than put more solder on there and create this huge ugly blob, I'm going to come up and melt this and have it come back over.
Turn it a little.
Boing, perfect. Without wasting more solder.
Gotcha.
Now we're going to recycle this last piece of wire.
And you're pretty confident that this is the main malfunction in this unit.
Yes.
Of course, testing on the oscilloscope will tell us
Yes, what else is going on?
what else is going on.
Yeah. The thing that happens with these is mainly tube related. Now, the other thing I'm going to replace in here, there are 3 small electrolytics that I'm going to replace just because they're old. But this is the main malfunction here. And then this wire will go back up to where
So
it
you
came from.
update what's appropriate.
Yes.
Not overkill, not underkill, just what's appropriate. I
Yes.
guess.
Yeah, and I like to use original values. But when people go, oh, I want my amp all original. Well, it didn't originally come with capacitors that were puking their guts out.
Yep.
So sometimes you have to make that.
Well, it's like you said, even with an old car, you've got to replace rings and camshaft. There's parts that have to be replaced because thermodynamics wears them out.
Now let's take a look at this. That's a correctly date-coded output transformer, but the wiring is horrific. So that tells me that at some point it must have been replaced, but with the correct part.
Now, when you say it's horrific, do you mean that they actually wired it wrong for the circuit, or it's just bad workmanship?
They didn't wire it wrong, but it just looks sloppy. Generally speaking, now the quality at Fender did deteriorate over the years, as far as the quality of the wiring. There was a woman. It used to be that in the Tweed era of Fenders, which was in the 50s and very early 60s, that the person who wired the amplifier would put their name on a piece of masking tape inside the amplifier, so you knew who wired it. And the most popular was Lupe. And I've seen a lot of Lupe amps, and I've also seen Lily amps, and I've also seen Herald amps. And so it's kind of neat to open one up and realize that Lupe had her hands on it. Well, then later years, after CBS bought the company in January '65, the overall lead dress and wiring quality kind of fell apart.
Yeah.
And so when I look at an amp like this, you kind of expect a certain standard if it's wired from the factory, but this doesn't even conform to that. So it's like this, here's an extra inch of wire that doesn't need to be in here. And the consequence of having extra wire is this promotes oscillations in a circuit. It's like when I've had so many amps come in that were modified by somebody like a Marshall, where somebody decided to put an effects loop in it or an extra gain stage. And this has created an oscillation that's maybe not audible, and the amp ends up oscillating itself to death. And a lot of them will have a little label on the back of who did it. So, and I won't mention any names.
Yeah.
But essentially, those amps would come out of pawn shops because they oscillated themselves to death. And you go in, and they just look like wire salad. You just start snipping the crap out when you get down to the stock circuit and rebuild it stock, and then the amp sounds fine. You replace the transformer that expired, and then everything's good to go. So what I think a lot of people don't understand, I'm not an engineer. I don't have any engineering chops. So I'm not interested in performing those kinds of things to an amplifier, because the part of the process of designing one of these is they engineer out the problems. They engineer out the oscillations. They're able to look at it on an oscilloscope and find out if it's malfunctioning at some frequency that's inaudible. So a homebrew guy doing a modification that hasn't been engineered to that extent can be hazardous to the amp's health. So that's why on my business card, my previous business card, it said D-modification, because I love taking these things out, putting the amps back to stock. And there's so many times when I've had customers say to me, man, my amp never sounded this good. I go, all I did was make it stock. I put it back the way it's supposed to be. It's like giving a car a tune-up. You make sure the bias is right, you make sure that all components are in good shape, and make sure the grounding is effective, and 9 times out of 10 the amp will sound better than it ever has, because they do deteriorate over time.
Excellent.
So
It makes sense that altering the original spec by feeding in extra lengths of wire, causing these deteriorative oscillations,
yes,
would really age the whole circuit. That makes sense to me.
yes, yeah, and it's
And now you're removing out the
yeah, these are some small electrolytic capacitors
electrolytic capacitors.
that have deteriorated over time. Now, I hopefully we won't get in trouble for mentioning names, but there was a period of time, Mallory is a great company, but there was a period of time when they made these small white electrolytics that did not last. These were not good capacitors, and I find them in a lot of this era of Fenders and Echoplexes and devices of that nature. And whenever I see them, I automatically replace them, because, in my opinion, they're probably not functional. They're not doing their job. Now, not to get into a bunch of tech blah blah, but the whole purpose of this bypass cap is to affect a low frequency cutoff and add gain to that stage of the circuit. So like Fender traditionally uses a 1.5K resistor and a 25 microfarad capacitor. If you lower the value of the capacitor, the point of the low frequency roll-off moves up. So like in a Marshall, they use a 0.68 microfarad capacitor, which absolutely gives you a much higher low frequency cutoff. And when you get rid of a whole lot of bottom end, it allows the amp to break up more readily. Like when the treble side of a Marshall, it breaks up, boom, boom, boom. Whereas a Fender has a tendency to sound a little more flubby because there's a lot more bottom end coming through.
So it induces distortion. No, incorrect.
I don't know if we could typify that as much as it changes the amount of bottom end that's coming through.
Shifts the frequencies.
Yes.
Okay.
And that's really an oversimplification of the whole thing.
Yeah, but we getting the idea.
Yeah.
Now these replacements you have are the Mallory's?
No, every tech, I'm sure, experiments with things over time and has certain preferences. I've been a fan of Nichicon capacitors for a long time. There are a lot of people that prefer to go with the American Sprague stuff, but I've had my share of bad Spragues, and I've to my knowledge, I've never had a bad Nichicon.
That's the Japanese.
Yes.
Well, they tend to have great quality control, great pride in their quality control.
And I totally love the product, and I've used it for a long time. So I like the Nichicons. I use the F&Ts for the power supply electrolytics because they're compact. They're awesome.
Just out of curiosity, are these easy for you to find in the LA area, or do you have to have long lead time to order them?
I actually order these. I have these brought in from
Japan.
No, a company called Mauser.
Oh. So all these components come from different suppliers, and
yes,
that's part of the upstream work you do to have a good shop.
And you establish your relationship with these vendors, and like it's a crack up that somebody will go, man, I've looked all over town for these. I go, well, come here, dude. I got all that stuff. You do have to seek this stuff out over time. Like, for example, I had a British product in here. It was a mic preamp, and it had a broken switch on the front. And there are 3 different places I could go within about a 2-mile radius that would have that particular part. So a lot of this stuff is universal. Well, there's not that much stuff that's actually totally proprietary, but when it is, then you kind of have to go to the source. And the controls, which are called potentiometers, that is the case with potentiometers. There are a lot of times when a specific potentiometer is needed because there are so many different configurations. Like you'll have smooth shaft, you'll have split shaft, you'll have knurled shaft, you'll have a 3/8 inch long shaft, you'll have an inch long shaft, you'll have different values. You have 1 meg, you have 250K, you have 500K, you have 5K. There are so many different parameters, you end up with big boxes of potentiometers just so you can service all the crap that's out there. Like, for example, when I converted a modern Fender amp over to a hand-wired amplifier, this was my prize. I got all these potentiometers that are mounted on this board and these input jacks. So this is something worth saving and recycling, because at some point a Fender amp will come in that needs one of these potentiometers, and then I'll have it.
And those pots will be okay, in your opinion, to reuse? Yes.
Yes. Now this is my all-in-one potentiometer stash bin. Whenever I have a potentiometer left over or something that's extra, I throw it in here. This is just the extra crap. I have 5 more boxes of potentiometers because there are just so many different kinds that are required. Here's another box of just completely different kinds of potentiometers in the different configurations. That's one of the biggest pains in the butt in this business, is trying to make sure that you have all the right proprietary type parts.
I gotcha. We're replacing the third
Electrolytic
capacitor.
Exactly right. Another problem in amp repair is a lot of times I'll open up something up and see exactly what I saw in this champ, which are what I consider bad repairs. I have to fix all that stuff, because the next person who sees it, if they see something that looks crappy, they go, "Oh, Roy Blankenship worked on that. Look at that mess," even if I didn't do it. So that's one of the other things that you don't get paid for in this business is fixing somebody else's bad workmanship.
And making sure the product works again properly.
So now that we've replaced those 3, here they are. And they don't look like they've been replaced. They look like they were there from the factory, which is, to me, is the way it needs to be. This is the giant capacitor that we just replaced, and everything is all back to normal. So now the other aspect of maintenance on this amplifier that's important is grounding. Now, by this stage of the game, Fender was soldering their grounding points, because a lot of times these nuts would loosen up. So as much as I might try, I may or may not be able to turn any of them.
Just for vibration, oxidation, those kinds of things? Yeah. Again, the laws of physics and thermodynamics working against us.
Yes. Okay, there's those. These loosen. So you can see those were loose. Then the other thing I like to do is spray out the potentiometers and the jacks.
Get them deoxidized, or cleaned up. Oh, that's just air.
No, it's a contact cleaner.
Mild contact cleaner. Gotcha.
Okay, and then it's important to dump out any potential leads.
And more than likely, the tubes are okay, correct?
Well, that's what we're going to find out right now. The fact that they're newer and replacement tubes. these have a special, most amplifiers have a 1/4 inch, what is called a 1/4 inch jack as an output. These use what's called an RCA, which is a smaller. It's interesting when you get into this and you realize how standard so many things are. So many of the parts are just standard stuff. So this is technically a 3.2 ohm load. The closest thing we have is a 4 ohm load, so we'll fire that up.
You're about to reintroduce raw electricity back into the circuit, correct?
And because the cap is new, technically you shouldn't have to form a modern capacitor, but I still like to take my time on it. So I'll fire this up to about 40 volts and see what we get.
You go slow on the initial load.
Yeah. This fuse tests good, but it's kind of a hokey fuse.
Did you just increase the load?
Yeah, I went up to 60 volts. And then we're going to check and verify that we have some things happening. This is the other super necessary tool. You can actually buy a reasonable meter for about $50. I've always liked Fluke brand meters. I have a couple that I've worn out just by virtue of everything. So first thing we're going to verify is we're going to come off this amp has a tube rectifier, which means it's taking the AC voltage is coming out of the power transformer into this tube rectifier, which is a tube version of a diode, which is like a one-way gate. A diode will take the AC that's traveling both directions and acts like a one-way gate. All of a sudden, once it gets past, it can't come back, which converts it to DC. And we're going to come down and verify that we have 235 volts on this point right here. So we have 235, and this is the first stage of the power supply. Then we have a resistor that isolates the first stage from the second stage. Second stage is measuring 231. Third stage, another resistor, is currently measuring 224. So there's some voltage drop, but not as much as there will be proportionally when we get the amp actually all cranked up. So let's put the
Now we're going to a full load.
I'm going to go up to about 90 and see if
90.
it comes to life. And you can see on the oscilloscope that we have signal even though we're only at 90 volts. Now we'll go up to 120. Let's see what happens.
Now, is that a good pattern in your opinion?
Yes, this is called a single-ended amplifier. It has a single power tube. So a lot of tube amplifiers have 2 or 4 or 6 or 8 power tubes that it's called a push-pull pair. Not getting into all this today, but this is a true Class A amplifier where this tube is conducting all the time. And because it is conducting all the time, we won't get the beautiful sine wave reproduction except down low. You can see there's the sine wave, and it's gorgeous. But as you turn it up, because it is only a single tube, it'll kind of start to contort a little bit. So there we are, 6 volts. So 6 times 6, 36, divided by 4 gives us our power. It's a 4-ohm load. So
We've repaired the amp.
we've repaired the amp.
Last test, plug it in, play guitar through it.
Right, and then I'll charge the guy $500.
But well deserved. He'll get what? Another decade or 2 decades out of this amp now.
It's true. It's true. All the components that were deteriorated have been replaced, and everything's looking good. Now this is called a cathode biased amplifier, where there's a resistor capacitor network to ground that sets the bias. So there's no setting the bias on this amplifier. It's it's auto setting. I hate to use the word auto bias because that's something that's overused, but that's the reality of it. And that the capacitor on that part had already been replaced, so I don't feel the need to replace it again. But after a while, you start to recognize situations where you're seeing the same thing over and over and over. Like, as in most of these amplifiers, they're the same thing over and over and over. Most boutique amplifiers, there's 1964 was about the peak of tone, and now most of the stuff that's made is not that different.
Well,
Those time periods. One of the most popular amps right now is called the 18-watt Marshall, which is actually a Watkins Dominator circuit that came out in 1964.
so now you've reconnected, you've reassembled, you're back into the almost operating mode here.
Yes, and I just verified that the speaker was never tightened up properly, so we tightened up the speaker, which that's another important thing. According to my acquaintance Harvey Gurst, who was the JBL engineer, and JBL being one of the more famous speaker companies on the planet,
High quality.
his idea about it is that you never really need more than 4 attachment points on a speaker. That'll have a tendency to warp the frame if you actually use 8.
Right.
Fender used 8, Celestion uses 4, this amp has 4 now because of the speaker change. But one of the important things to me in mounting a speaker is a lot of guys, they want to crank them down. You don't have to crank them down. Hand tight with a nut driver is completely fine. There's no need to put a heavy honking impact wrench on it. You're just going to warp the frame and cause a voice coil rub, which
Ages everything again.
yeah, that's the end of it. That's the end of it.
That's the end of it.
Okay. Now, before we put the front panel on, I have 2 shop guitars that represent single coils and humbuckers, so I can hear what each sounds like through an amplifier. This amplifier isn't really necessary to test with a humbucker, and I usually have this tuned to this open G tuning that I love. Okay.
Clear and beautiful.
So there's no noise, everything's working the way it's supposed to, done.
Done.